Hi, today's class is deletion of a node in a doubly linked list. How to delete a node? What is the process we are used to delete a node in a doubly linked list? So, what is the different approach? Is the previous one. So, what is the procedure to delete a node in a single list? So, what is the approach? When the list is empty, we cannot delete the element from that. If the list is empty, if the list is not empty, then search whether the element, so where the element is. After setting the search, then we can delete the element. If it is a first node, the starting address is changed. So if it is an intermediate node, so we can delete the element. So we already know that the advantage of dynamic memory allocation is, so we can easily delete an element from the array, from the list. So we can very easy to delete the element from a list. So in order to delete an element from the list, first of all, you have to search where the element is. After finding the element, then we can delete the elements. So delete to delete the element from the list, search to delete the element from the list, search whether the element is first search whether the list is empty or not. Whether the is empty or not. So first to delete an element from the list, to delete an element from the list, first check whether the element is whether the list is empty or not. Whether the list is empty or not. So if the list is not empty, the list is not empty, then if the list is not empty, then delete. The list is not empty, then delete the and check where the element is. When the list is when the element is found, when the element is found, then delete the node from the list. So what is the process to delete a node from a list? So to delete a node in a linked list, first check to the first to delete a list or to delete an element from a list. First we have to check whether the list is empty or not. If the list is not empty, so then check where the element is. So after finding the element, then we can delete the element. So for example, this is my list. is the first list. 1, 2000. 2, 3000. 21. 32. 33. So this is my list. So this is the first node. Node address is stored in start variable. So this is the address 1000. The second node address 2000. Second node address is stored in first node. This is the third node address. Third node address 3000. The fourth node address 4000. So like this we have the list. Suppose I want to delete 32. How I can delete 32? First of all, you have to check whether 32 is in the list or not. So we know that we have only first node address. First we check the first node, the value contained in the first node. When both are equal, then the element is found, then we can delete. Otherwise, so we'll check the 32 in second node. So if the 32 value 32 and 21 is same, no. So again go for third node, 32 and 32. Yes, both are equal. Then the element is found. So when the element is found, then we can delete the element. How we can delete? So you have to assign. We know delete is a operator. By using delete operator, we can delete the element. This is the process we are using to delete a node from a single linked list. Algorithm delete node. How we delete a node from W linked list? First, we have to read the number. The number to be deleted. Read the number to be deleted. We have to read which number to be deleted. Cn I will call as n. And second point. Check the list is empty or not. So otherwise, traverse check the number in the list. Number. So I will check the number. So first we have to assign first node variable to one variable current equals stop. So while current not equal to null, and found not equal to. If current arrow number is equal to n, if current arrow number equal to n, so that means the list in the number in the list is equal to deleted number. So then element is found equal to 1, equal to 1. Otherwise, we can go for next node. So I will move to next node. So then previous equal to current, current equal to current arrow. So like this, we can set whether the element is check the number, if the number is found or not. If the number is in the list, then the found value is 1. If the number is not in the list, found value is 0. So if the number is in the list, then we can delete. Found equal to 1. The number is in the list. The number is in the list, then we can, so we'll say found equal to 1. Delete. The process we use previous dot next equal to current arrow next. Process we are using to delete a node from a double linked list. Sorry, from a linked list, not double. So this is the process. This is the algorithm we are using to delete a node in a linked list. So how to delete a node in a linked list? So this is the, what is the approach for deletion of a node in a linked list. So you have to check whether the element is in the. First of all, you have to read the number, which node to be deleted. So after reading the number, check whether the number is in the list or not. So to check the number, we start from the first node, current equal to start, while current dot next not equal to null, we can move to next node. So like this, we can move whether the number is in the list or not. When the number is in the list, then we can connect we can delete the current node, and the previous node is connected to current dot next. The deleted node before node is in previous, deleted next node is the current dot next. So when the deleted node is current, deleted node before node is previous, deleted node next node is current. So previous dot next equal to current dot next, then we can delete the current node. This is the process we are using to delete a node in a list. Similarly, in the position also same we are using, instead of this we are using position I++. So we can delete a node or deleted position. So we can write two modules, deleted position and delete node. Both so suppose we want to delete a number, suppose I want to delete 10, 21, 32, 33 like this. So we use this model. Delete position, this is the first position, this second, this third, this fourth. So want to delete at first position or second position, third position, fourth position, or so delete nodes like this. So this is the process we are using. Then we go for implementation. how to implement. Students outside thing. So students are understand the concept, delete, how to delete a node, whether you are understand or not. No student is responded. Yes. Once we delete, this is the process, actually this is the algorithm. So once you know that, then we can delete the node automatically. Okay. Say once again, organize. So let us assume that this is the list. So I want to delete a node from this list. So to delete a node from this list, first of all, you have to read which node to be deleted, which number node to be deleted. Suppose that is the n. Suppose if the n value is 21, check whether 21 is in the list or not. If n value is 32, check whether 32 is in the list or not. If n value is 50, check 50 is in the list or not. Like this, we will check whether the number is in the list or not. So when the number is, first of all, you have to read n value. After read the n value, you have to check the n value whether it is in the list or not. To check the n value, we start from first node. You have to check the first node. So we already know that the first node address is stored at current. So current, I will check the current number with respect to the n. So when both are equal, so then we can delete. Suppose that deleted number is 32, n value is 10. So 10 equal to 32? No. So we can traverse from this node to next node. So to move from one node to another node, we use current equal to current dot next. So before moving to next node, the previous node is assigned to current previous. So that's why previous equal to current. This node becomes previous. This node is the current. Now we will check it at 21, 32. 21 equal to 32? No. So now it is previous. This is current. Both are equal? Yes. If it is equal, then the found value equal to 1. When the found equal to 1 indicates the number is in the list. When the found equal to 0, when the element is not in the list. So when it is equal, then we can delete. So this is the previous, this is the current, this is current dot next. This node is called as the previous node. This is the current node. This is the current dot next. So you have to connect current previous dot next to current dot next and delete current node. So this is the process we are using to delete a node from a list. So this is the approach. This is the approach. Then we go for implementation. How to implement? Void delete node. Void delete node. So this is the algorithm. So I want to implement this module. Void SLL colon delete node. Void SLL delete node. So node star previous is one temporary variable int n comma found equal to 0. N comma found equal to 0. First of all, we have to read which node to be deleted. Cout. Enter the number to be deleted. Number to be deleted. In n. If n equal to 5, we have to delete 5. If n equal to 7, you have to delete 7. If n equal to 8, you have to delete 8. Like this, you have to delete. So to delete a node, so first we have to assign the first node address to one variable called as start. We already know that always the first node address is stored in start. That's why assign the current node address to start node address to current. While current not equal to null, while current not equal to null, and found not equal to 1, while current not equal to null and found not equal to 1. If current arrow number is equal to n, if current arrow number equal to n, found equal to 1, break. Found equal to 1, break. So we have otherwise go for next node, previous equal to current, current equal to current arrow next. So this is the process we are using to delete it. First of all, you have to check whether the number is in the list or not. So it is same as insertion also same. So current equal to start. First you have to assign starting node address to current variable, while current not equal to null and found not equal to 1. If current number equal to n, found equal to 1, break. Otherwise go for next node. How will go for next node? Previous equal to current, current equal to current of next. This is the process we are using to check whether the number is in the list or not. If the number is in the list, we say that so I will say that found equal to 1, the number is in list. Found equal to 0, the number is not in the list. So found equal to 0, it's not in the list. Found equal to 0, number is not in the list. Else number is in the list. If the number is in the list, then it may be either first node or intermediate node. If it is a first node, if how we say that if it is a first node, current equal to star. First node, then you have to change the first node at start equal to current dot next. Then delete current. Start equal to current dot next, then delete current. It is a first node. So we say that it is a first node, current equal to start. If current equal to start, then start equal to current dot next, delete current. Else, if it is not a first node, if it is an intermediate node, if it is a intermediate node, if it is not a first node, it is not a first node, if it is an intermediate node, so then delete previous dot next equal to current dot next. Previous dot next equal to current dot next. So this is the process. This is the end of the module. Then you go for display, delete end, no, delete node, delete node. So enter the number 1. Suppose 10. You want another node? Yes. 15. Yes. 16. Yes. 20. Yes. 25. You want another node? Yes. So this is the 10, 15, 16, 20, 25. Suppose I want to delete 16. So enter the number to be delete 16. So when I delete the 16, the list is 10, 15, 20, and 25. This is the process. So this is the way to delete a node in a list. So how to delete the search? First of all, you have to search whether the number is in the list or not. That's the main part. If the number is in the list, then we can delete. If the number is not in the list, we cannot. So if the number is in the list, then we can delete the node from the list. This is the process we are using. So what is the process? First of all, you have to read which number to be deleted. So then check whether the number is in the list or not. So to check whether the number is in the list or not, we know that the first node address is always stored at start. So current is assigned to start. While current dot next not equal to null and found not equal to 1. So if it is not equal to, if it is not null and current found not equal to 1, check current number equal to n, found equal to 1 break. So that means the number in the list is equal to deleted number. Current dot number means the number in the number in the list is equal to deleted number, found equal to 1 break. Else we go for next node. So to move from one node to another node, we use current equal to current dot next. However, the previous address is assigned to previous equal to current equal to current dot next. So this is the process we use to find to move from one node to another node. If the number is in the list, so how we say that the number is in the list found equal to 1? If found equal to 0, the number is not in the list. If found equal to 1, the number is in the list. If the number is in the list, then we check whether it is the first node or intermediate node. So how we say that first node current equal to start? Current equal start. How to change the first node address? Start equal to current dot next. Delete current. Else, otherwise. So we know that the deleted node before is previous. Deleted next is current dot next. So that previous dot next equal to current dot next. Delete current. So this is the process we are using to delete a node from a list. This is the process. So this is the delete node. This is the delete node module. So to delete. Similarly, we can use delete at position also. So delete position. So somebody will ask the delete at second position, no, delete at third position, delete at fourth position. So we can write also that is also same. So I will write that module also. Void delete POS position. Delete at position. So delete middle. We will say that delete position. Void SLL in position into position. So POS is the position into position. So then what the position to be deleted, and we required one variable I equal to 1. See out. Enter the position of the node to be deleted. Enter the position of the node to be deleted. See in position. If position equal to 1, you have to delete at first node. If position is 2, you have to delete second node. If position is 3, you have to delete third node, like this. So current equal to position. So current equal to start, while I less than position and current not equal to null. You have to, if it is null, indicates the list is empty. That's why. So you have to move from one position to another node position I plus current equal to current arrow next. So I use current equal to current dot next. So it is moved from one position to another position, while I less than position and current not equal to null. I plus current equal to current dot next. Like this, we move from one position to second to third to fourth to fifth, like this. So once the element is found, so how we say that if current not equal to null, current not equal to null. If current equal to null, the list is empty. If current not equal to null, means that list is not empty. So if it is a valid position like this, so then you have to check if it is the first node. How we say that if current equal to start. if current equal to start. So previous equal to current also. Previous equal to current, current equal to, if current equal to start, if it is a first node. So if it is a first node, how to change the first node address, start equal to current arrow next, then delete current. Start equal to current dot next, then delete current. Else, if it is not a first node, previous dot next, current dot next, previous dot next equal to current dot next, delete current. So this is the process. If start equal to current equal start, you have to change the first node address. So that's why current start equal to current dot next, delete current. Otherwise, you have to connect the previous node to existing node. So that's why previous dot next equal to current dot next, which is same. Else, print out. So this is the model. Node, we use delete position. So you have to enter. Suppose this is the first number 10. Do you want to enter another node? Second number 21. Yes. 33. Yes. 45. Yes. 56. No. So this is the 10, 21, 33, 45, 56. Suppose I want to delete a third position 3. So then the third position element is deleted 10, 21, 45, 56. 33 is deleted. So it is same actually. The only difference is this is also this is complete same. So the only difference is the position. So here you are blindly move from one position to another position. So this is the process. While in the case of deletion, number deletion, we have to write. So like this, we can write the module. So after that, we finally create this. All the modules. These are all different modules that are available. So that we can perform on W linked list. Similarly, is linked list. We have one more module called as reverse. A reverse of a, so this is the reverse is one not somewhat complicated process because we know the next node address, but we do not know the previous node address. That's why reverse is somewhat difficult in singly linked list. However, so it is possible to write. So it is a it's an expensive process. So okay. So it is also possible to write the delete module also void reverse. Void reverse. This is the complete program. So once we completed, it will be nearly 250 lines plus program. So void SLL single linked list reverse the program. That's why I told already students. So the single data structure is very difficult to implement because the programs are very big. Now you see the So it is clearly 220 lines. So after creation of the main also it becomes 250 plus lines. So remembering by hearting the subject is very difficult. Only you have to understand the concept. Once you can understand the concept, we can write very easily. So without understanding the concept, you cannot write. So how we can node equal to star last. I'll take one module. So first of all, we have to move from last node. How we can identify the last node? How we can identify the last node? While current arrow next not equal to null. Current equal to current arrow next not equal to null. So we can move from current equal to current. By using this line, this path, we can move to last. After moving the last node, then we can print the elements. See out current arrow number. So for again we move to first node, CURR equal to start. While current arrow next not equal to last. Current equal to current dot next. So again move to last node. So we are already assigned to last node address to last. Here I will assign the last. So last equal to current. So we know that the first node address is stored in start and last node address is stored at last. So again, so while current again we go for first node and move to last. While current dot next not equal to next, current equal to current dot next. Once you move to last node, then you have to print cout current arrow number. Current arrow number. Cout current arrow number. So after that, so you have to continue this process again. So why current last not equal to starting. So this is the process we are using to reverse a list. First of all, you have to move to last node. How we move to last node? So while how you can identify the last node? So the last node can be identified when the dot next is null. So that's way while current dot next not equal to null, we can move from current to current dot next. So when we move to current equal to current dot next, we move to last node. Once we move to last node, we print that node and I'll assign that last node address to last. Again, I'll move to first node and from first node to again move to last node. Current equal to start. So and while current dot next not equal to last, current equal to current dot next. Cout current arrow number. So this is the process we are in. So like this we move up to current not equal, last not equal to start. So then we print the in reverse. This one dot rows. So this is the process we are using. First I create this and then next. One cout. Enter the number 10 is 20 is 30 is 45. You want to know Yes. So Okay. So this is the end of today's class.